I did have to talk about one problem from the notes, and then after that, we can go over the test review, which I did put up pretty much a summary of the topics we've discussed on Moodle. You'll see it when you go into Moodle. And I'll just kind of talk through, it pretty much resonates with the topics that we're going over in the homework. But before I do that, let me go ahead and finish that one problem I have to do. It's that one problem. So last time we talked about distance across the lake. We did example 3 in class last time. So there's one more thing oh wait, no we didn't, I'm sorry. Let me take that back. I assigned that one for homework. Yeah, so I didn't really think about it.
You moved it to, instead of 47, you moved that one.
Yeah, you're right. Okay, so this one, I took out one of the homework problems and I made example 3 the homework problem. We did example 2. And so example 3 is now the homework problem. And I was debating whether that final homework should be optional or if I should make it due. So I don't really like making things due on a test. I don't know. Suggestions? One more homework, or should I make it optional? And if you turn it in, I'll grade it. I'll try to grade it quickly. For optional?
Yeah, would you take homework assignments over the weekend?
I don't mind. I'll take homework. Like I said, I like trig. I don't mind. Okay. I can make it optional. If it's optional, of course, it won't be for a grade. If you don't turn it in, nothing happens. If you turn it in, I'll just give you feedback. As if, I won't make it for a grade. I'll just give you feedback on what you turn in. So in particular, because I feel, if anything, the section on 2.3, it's calculator stuff. So I could just look at it and say, you're doing it correct in the calculator. And then here, it's just a few problems, which you can do. So the homework on 2.3 and 2.4, I guess that's optional. Just optional. If you turn it in, I'll just give you feedback. It won't be for a grade. So if you don't want to do it, you don't have to. So, and you can turn it in whenever you want. Obviously, the sooner you turn it in, the sooner I can receive it and give you feedback. So with that being said, so those 2 sections are optional. So you can do them if you want. You don't have to. I don't care either way. I'll talk about the assessment in a bit, the Unit 1 assessment or test, whatever I call it. Let me get through this problem first. And it's nothing too crazy. So this is the angle of elevation or angle of depression, which is one of 2 things. From standard position, a standard position, it's either the distance up from the x-axis, which of course would be elevation, or it may be the distance down from the x-axis. And guess what? That's depression. I didn't mean to start talking about depression in class, but hopefully it's not too morbid for all of you. So, angle of elevation just goes up, depression goes down. Simple enough. So, let's look at example 4. Just a quick example of this, and then that's going to be everything leading up to the test. And so something about there's an airplane that's flying 10,500 feet above the ground. So here's the ground. Here's an airplane. So its distance from the ground is 10,500. The angle of depression from the plane to the base of a tree. So tree. Don't trees have leaves? Yeah, so tree. So the angle of depression from the plane to the base of the tree. So remember the base of the tree is right here. So I guess the question is, which one is the angle? So since it's from the plane to the base of the tree, really the angle is right here. This is the 13 degrees, 50 minutes. That's the angle from the plane to the base of the tree. And then the problem wants us to determine how far does the plane have to go, how far horizontally, until it's directly over the tree. So you might be able to see a right triangle. In fact, you might be able to see two right triangles here. And so how far horizontally? So this is the unknown. That's what we're trying to figure out. So there's really a few ways you can go about this. Really what I like to do is think about that same distance down here. So this distance, I'm looking at it equivalently down here. And you don't have to do it this way. But if you do it this way, that means you have to find out this angle, which is going to be, does anyone remember the terminology? It's complement. Yeah, it's the complement. So this would be simply 90 degrees minus 13 degrees and 50 minutes, which you can do in the calculator. (90 minus 13 degrees, 50 minutes. And so if you do everything correctly, you will get 76 degrees, 10 minutes. And as you can tell, I'm making you do it this way, or not making you, but I'm doing it this way primarily to just practice that DMS stuff, that conversion to DMS. But now we have a right triangle with an angle, a given side, and some unknown. So how can we turn that into results? Does anyone have any clue whatsoever how this can be turned into something meaningful? Any clue at all? We have an angle and a side. We need to know another side. What relates angles and sides? Yeah, the trig functions. The trig functions relate sides and angles. So trig functions. So that's directly it. It's trig functions. Trig functions associate or allow sides and angles to associate in some way. So in particular, well, we take the trig function of an angle. So it's going to be some trig function, I'll put, a blank here, of 76 degrees in 10 minutes. We need some trig function here. This trig function needs to utilize the information we know and the information we want to find out. What trig function would satisfy that?
You need to find out adjacent and have opposite.
So adjacent and what did you say again?
Opposite.
Yes. So which trig function or functions deal with adjacent and opposite?
Tangent.
It's tangent or cotangent, either or. I'm going to pick tangent because that one's on the calculator. So tangent, because tangent is opposite over adjacent. So that question mark, I'll just put an X, it doesn't matter, divided by 10,500. And so if you set that up correctly, all you have to do is multiply. So how many feet? Doesn't really say how many decimal places. I'll put 2. I don't know. It doesn't matter. That many feet. At least that's what I got. Cool. So that would be it. Does anyone have any questions? All right, so that's everything up to the exam. And I suppose now it would be appropriate to start talking about the Unit 1 exam. So, Unit 1 exam, you will notice it says in Moodle, Unit Exam 1 Review. So when you click on that, so it's not like I'm going to give you the problems that will be on the test. Because what really is the case here is that these themes go directly off of your homework. And so your homework is your best, in fact, really your only way of studying for this test, unless you want to read the book as well. So the test itself is going to be in Moodle. So this is a Moodle test. It's split up into 3 portions. First portion is multiple choice. Questions like, is this function in the range? Where's it at? Something about a range. Yes, there's something like this perhaps. Is a trig function in a range or not? A problem like that can be in there. It's multiple choice. You say possible or not possible. Or another situation could be, given some angle, what is the complement or the supplement? There's a bunch of multiple choice and you just click on one. That's one portion of the test, just a bunch of multiple choice, I think maybe like 8 or something. And then the next part are short answers. It's either answers that you type in the number that you get. Say if you're asked to find the trig function of a number, you put it in the calculator and then you type it into Moodle, whatever that number is. So you type in the answer. It's not really any work to show. You just type in whatever answer you get. So it's a little bit more engaged, but nothing crazy. And then the third portion of the test is going to be problems such as maybe reference angles and their applications, maybe an application or two. And so what these problems will have is just a text box. And with this text box, so this is where your partial credit's going to come into play. You're going to put not all of your scratch work. I don't need all of your scratch work in this text box. So you could think about this text box as if we're typing stuff into Word. God, I hate Word. But Notepad, fine, whatever. You can think about it as if you were typing into Notepad. So one question we've looked at already is, where's it at? So if you have a question with X, Y's, and R's, so for example, example 2 or something, it gives you this point and then it asks you to find R. So normally the way you would find R, at least in example 2, R is equal to the square roots of -5 squared plus 12 squared, which is 13. And then in the Notepad style, you could put R is the square root of, or some people just do square root -5 squared plus 2 squared. And I'm super relaxed on how you type this in. I will be able to figure it out. I did this for my last trig class and they figured it out really easily. I'm very forgiving. Some people put square for square root and I accepted that because I knew what you were talking about. So I promise it's not that bad. I gave you 10 extra minutes on the test just so you could kind of formulate the steps in your mind. But really, SQRT of all of this, whatever I said, 12, which is 69. Something like that. That would be sufficient for showing your work. You don't have to show me every little step. Like if you have to draw a triangle, I had one student literally draw this kind of junk for the triangle, and it was really impressive. He actually did this for the triangle. You do not have to do this. Please don't do this.
Some underscores in the middle of it.
Yeah, something like that. He did that, and he had the labels next to it. I mean, he was cheating. So I figured that out pretty quickly, that he copy and pasted from somewhere. So it was clever. It was too good. It was way too good. So don't do that.
It took like 20 minutes just to type up a triangle.
It was remarkable that he didn't do any of the homeworks, and yet he got 100 on the first test. The proctored test, it was weird how he failed it.
Yeah.
Just very strange how that worked out. But if you cheat, your students are just not very good at cheating. I could tell. It's pretty easy to tell when someone's cheating. But
It was probably something like, this is going to be a breeze.
I mean, that's well, that was until he failed the class.
Yep.
So yeah, so you don't have to put triangles and stuff. And if you need to show scratch work, I generally provide, and after the description of the problem, it'll say, the obvious show your work. And then right after it, it'll say, by show your work, I mean, Then step 1, show this part. Step 2, show this part. And I ask you pretty much how to show your work, because I understand that I'm just throwing you into this. This is really weird because we can't all take the test in person. So this is pretty much the method for the first assessment. So stuff like that, I promise it's not that bad, and I am very forgiving about how you type stuff in. So yeah, just wanted to give you an idea that this is the way in which answers will be put into Moodle. So you are not giving me any scratch work, no scratch work. Let's see, what else? So yeah, and this will open up Monday at 8 a.m. It'll close Tuesday at 11:59 p.m. Yes. But that does not mean you could take the test at 11:59 p.m. because it will close after 1 minute. So honestly, you have until like 10:29 p.m. because you have 100 minutes to take it. So is that math right? Probably not. 10 to 20?
It is. I just checked it.
I don't know. I'm not very good at math. So do not wait until 11 o'clock to take the test because it'll cut you out at 11:59. So let's see, what else is there? You take the test in Moodle. I'll go over in a second what to expect, or just kind of a general outline of what to expect. Kind of explain how the answers are going to be inputted into Moodle. I think there's 23 questions in total. The 2/3 of the test are either multiple choice or the short answer. So you should be able to get through those fairly quickly. That leaves the other third as the intricate ones where you have to show work and everything. It's 100 minutes. If you have any accommodations, then that's going to be bumped up to 150 minutes. And I suppose let's go ahead and just talk about the problems in general. So, like I said, this is posted in Moodle, and it pretty much talks about and generalizes the problems from the homework. And then after I go through all of this, I'll pretty much make it I'll work homework problems, like past homework problems, present homework problems. Everything's already been turned in, so I don't mind. So section 1.1, determine the type of angle. You might be given some information about some angle. You might be told it's 80 something degrees, and then you would tell me it's an acute, well, angle in this case. So it could be something as simple as that, just some geometry. Finding the complement or the supplement. Remember, that's two angles that add up to be 90 or 180. Convert decimal degrees to DMS or convert DMS to decimal degrees. So that means you need to know how to do that in the calculator. If I give a final answer and I say put it in degrees, minutes, second form, and you don't do that, I'll probably take off half a point and say shame on you. So make sure you know how to do that, or it could just be a specific problem that says convert this to that, and then you fill it in really quickly by converting in your calculator. Be able to determine coterminal angles. Remember how to find coterminal angles? Well, do you?
Yeah.
Yeah. Well, how?
Add and subtract 360.
Yeah, add and subtract 360. Just multiples of 360. It's a good thing I asked. Yeah, so it's just add or subtract 360. So might be good to go back and make that a refresher. Coterminal, you add or subtract 360. Section 1.2. Transversal, if there's some sort of transversal diagram given, you know how the angles relate. And I gave the whole diagram on the first page of that section. Determine the third angle given two other angles. Well, if you're given two angles of a triangle and you're trying to find the third angle, then naturally you want to,
As to subtract from one angle.
yeah, I'm going to just assume that that's the right thing. Both of what you said just kind of blended together, so I'm going to assume that's right. Yeah, you take 180 and subtract the two known angles, and then you get the third angle. Classify a given triangle given the angles, so more of what you said earlier. So remember, we have a right triangle, an acute triangle, and an obtuse triangle. So if I were to just give you some descriptions of a triangle, you'd have to figure those out, as well as, I mean, determine if a triangle is equilateral, isosceles, or scalene, given the sides.
So what would that say, like, this triangle has an angle greater than 90 degrees, obtuse?
Well, I mean, let's see, for problem 4, it would just say, some triangle has a side of 4 inches, 5 inches, and 6 inches. What kind of triangle is it?
What about for like acute, right, and obtuse?
This angle, or this triangle has angles of 60 degrees, 30 degrees, and 30 degrees, or something like that, or 90. The math's off, but you see what I mean. So it'll just state what the sides or the angles are, and then you just, I mean, really, that would be a multiple choice kind of question. Section 1.3 gets a little bit more interesting. So determine X, Y, and R given a point. So you did a few problems like that in the homework. And then provide the trig functions for each one. So that means those formulas. Remember, sine is y over r, and cosine is x over r. Tangent, y over x. Or if you can use triangulation, you're welcome to do that. Now, obviously, don't draw a triangle on my test. I'm happy to see it and kind of laugh at it, but it takes more time for you to draw a nice triangle. I wouldn't imagine any of you are going to do that. I mean, if you have time at the end of the test and you just want to see if you can, just ignore that. Never mind. Never mind. Just don't do it. It's just a waste of time. Yeah, you don't have to show me a triangle. Use the calculator to find a trig value. Use a calculator to find a power of a trig function. So calculator problems, that probably be either a multiple choice or a short answer. Determine whether a trig statement is possible or not. That's the range stuff. Remember, sine and cosine, their outputs can only be between -1 and 1. Secant and cosecant, they're everything but the values in between -1 and 1. Tangent and cotangent don't care at all. Identify the quadrant or quadrants given the sign of one trig function, or possibly more trig functions, to be honest. So this is actually, I graded one of these on the homework. I just graded all the 1.3 and 1.4 homework. So one of the ones I graded was one of these quadrant problems. So if I gave you one sign of a trig function, if I told you that cotangent was negative, then you would think, okay, well, tangent's negative. Okay, now where does that fit on the all students take calculus thing?
1, 2, 3.
Yeah, so I already forgot what I said, but I'll take your word for it there. That's fine. Okay, cool. So solving trig equations, finding a solution. I think that's a fair problem. Remember, there's 2 situations we had for solving trig equations. There was that cofunction thing. So I'm trying to remember the problems. Yeah, one of them you had to use a cofunction. In fact, I have the notes right here. Okay, so example 6 from the notes. That was solve an equation. So that used a reciprocal identity, rather. And then there was another trig equation where you had to use a cofunction. Example 3 here. Both of those are fair game. Maybe both at the same time. So determine exact values for quadrantal angles. Now, what makes a quadrantal so special? Can't use a triangle, which means you have to use X, Y, and R. So if you get a quadrantal angle, and guess what? You need to use X, Y, and R, especially if the problem says don't use the calculator. So the quotient identities to find another trig function. I mean, the quotient identities. Where's that? Didn't really talk about quotient identities too much, so you can probably just ignore that part. We didn't really mention that sine divided by cosine is tangent too explicitly. We will later on, so you can ignore that part. Write a trig function in terms of its cofunction. So things like example 2 here. Solve trig equations, I just mentioned that earlier. So that's another situation in which you could solve a trig equation using cofunctions, i.e. getting the same trig function on both sides so you can cancel them out. And of course, the main thing, use special triangles to find the missing side values. So we didn't touch equilateral triangles, but yeah, these two special triangles, using those to figure out the trig values. So that implies, say, if I were to give you a similar, or a triangle in which you have to use similar triangles, something of that nature. Find the reference angle. So of course, if I gave you some angle, be able to tell me the reference angle. Or I could take it a step further and ask you to determine the trig values of non-acute angles, which was the stuff we did down here, in which you had to find a reference angle anyways, and then figure out the sides of the triangle possibly in order to determine the value. So like example 3 on page 18 here. So section 2.3 should be straightforward. Use the calculator to find trig values or inverse trig values. So the stuff we talked about last time, as well as, so any problems we did here are fair game, as well as if I give you two sides and an angle. So if I gave you two sides and one angle, or if I gave you really two angles and one side, and technically the second angle is really easy to find. I mean, technically that's the second angle, but if I gave you two angles and one side, that's fair game. And then there could be one of these application problems on there. Something about doing that one. Something about elevation or depression. So really, this goes off of the notes and the homework directly. And when I gave this test over the summer, same questions, or yeah, same questions, same time. Everyone was able to finish it on time. So that shouldn't be an issue going off of that sample size. Everyone was able to finish. So that shouldn't be an issue. Besides for that, I really don't have much to add on my own end. So at this point, I can answer any homework questions. If you have any questions about the test, I can answer those. Otherwise, pretty much it's your turn to ask me stuff. And if
I
you
have a
have
question about number 76 on 2.3.
Sure. Yeah, and if you don't have anything or you're tired of hearing me talk, you can bounce whenever. I don't care. So which one?
76 on 1.3.
76 and 13?
2.3.
2-3, gotcha.
Yeah, it's current homework that we're trying to do tomorrow.
You said 73.
76.
76, darn it. You said 2-3?
2-1, I'm sorry. It's
I was about
2-1.
to say that problem looked horrible. A 2-1?
Yeah.
Okay. This one looks familiar. So I had someone ask me about this one.
I was going to email you about it, but I was like, I'll probably just ask him in class.
Well, I already had an impromptu, I guess, meeting with somebody over this question. I can definitely go through it again.
When I looked at the notes to try and like help me with our notes gave us, it was the similar or same, I believe it was, they're both 30-60s and this one's a 45-45 and the other one is a 30-60.
Okay.
So I didn't know.
So let's see. What is the easiest way? I did this before. Just want a blank sheet. I know I did this before. Screw it. I'll do it the less fun way. Okay, so the problem, it's 76. This is page 55 of the textbook. This is from the homework 2.1. Cannot draw to save my life. I'll draw this one first. Right triangle, 60 degrees. There's an A here, there's a 7, there's an M, there's an N, there's a 45 degrees, and there's a Q. Okay, cool. So we have two triangles here. One of these triangles is more pertinent than the other. Which triangle is it more reasonable to look at first?
One with the 7.
The one with the 7, because that actually gives us more information. It actually gives us one of the side values. The leftmost triangle doesn't give us any side values, which will really hurt us later, as you will see momentarily. So let's write out that rightmost triangle. I'm just writing it off to the side. So there's a 7, there's a 60, there's an A, and there's an M. Now the problem here, so we see that this is hopefully we see that this is a 30-60 triangle. And now the question is, all right, so what? How do we utilize that? What does that mean? And so what that means is that we need some sort of template. We need some sort of, I'm going to write this in red because this is not true. It's not you getting to say, oh, square root of 3 somewhere, 1 here, and you put 2 here. No, that's not how this works. You have to use similar triangles because what you have I mean, you identified that this is a 30-60 triangle, but the 30-60 triangle, the special triangle, is a similar triangle to this one. So basically, the triangle you have now is that special triangle, and you just completely enlarged it. That means every side value increased the same amount. So basically, what's happening is if we write the special triangle with all the side values that we're familiar with, then we can start comparing the two and see how they all change together. So this will be the special triangle here. So how do we fill in these sides? Because it's not like we could just put in anything at our discretion.
The opposite of 60, the one across from 60 is going to be the square root of 3.
Yeah, that one has to be the square root of 3. The one across from 60 has to be the square root of 3. It has to.
The one across from the 30, which is the angle up top, would be 1.
That's right.
And then the one across from the 90 degrees would be 2.
Yeah, so the hypotenuse is always consistent. The one across from 60 has to be the square root of 3, and then adjacent of 60 has to be 1. If you switch it up, all of your answers are going to be switched, which doesn't, I mean, it definitely changes a lot, but it's not too crazy. But regardless, now we have two triangles, which are guaranteed to be similar triangles. What's so helpful about this, why we wanted to pick the triangle that had a given value, was because now we have a ratio, a completed ratio of corresponding sides. We know that we took the square root of 3, we did some algebraic magic to it, and then we got 7. That gives us a ratio. That gives us some sort of correspondence. If we would have picked the left triangle, we would have never had a completed ratio because none of those side values were given to us. But now that we have this completed ratio, so square root of 3 ratio just means fraction, and then something with a 7, because that's the corresponding side. Now with similar triangles, the ratios between corresponding sides are the exact same. So what would be another comparison of corresponding sides?
2 over A.
2 and A, they're both hypotenuse values. So that's another correspondence of sides.
So could you also do it as like 7 over the square root of 3 and then A over 2?
Yes, you can do it in that order as well. So the ratio of corresponding sides is the same as long as you are consistent. We went from right triangle to left triangle, and then we also have to do right triangle to left triangle in terms of the fractions. So square root of 3 goes in the numerator, and that means the 2 from the same triangle has to go in the numerator. And then we get this. And we can cross multiply. Square root of 3a is equal to 7 times 2, which is 14. Finally, a is equal to 14 divided by the square root of 3. We didn't have to solve for a first. We could have also solved for m first. It doesn't matter.
M actually probably would have been easier because of the other one.
Well, we saved the easier one for last then. So that helped us find a. So we have a, and now we can go ahead and find m. So we have a ratio already, square root of 3 over 7, which we don't have to, we don't want to use a and 2, because that'd be 14 over square root of 3 divided by 2, which is, So we have a completed ratio already, and now we have a new collection of corresponding sides, which I've now circled in blue. Now I guess this would have been good to have them flipped, but it doesn't matter. 1 would have to go in the numerator because we're picking the right triangle first, and then M would have to go in the bottom. But it's not that bad to clean up. And if you're into rationalizing the denominator, which again, you don't have to do. You can do it as such. It's up to you. I really don't care. Oops. So that would just be the values for the right triangle. We still haven't even gotten to the left triangle. So the left triangle, I'm just going to rewrite it down here. I'm going to write it upright as well. There's 45 degrees and then something else. Q, N, and A. So there was a Q here, there was an N here, and there's an A here. But we can fill in one of these sides. We know that A, we found it in the previous part, is 14 over the square root of 3. So now we can actually do something about this. So now we have one of the sides, and we think about, all right, what can we compare this to? This is a 45-45 triangle. So this is the special triangle that we're writing here on the right. Why did I write it so close to the base of the triangle? I don't know. It's special. Okay, it's special. So what are the dimensions of a 45-45 triangle? 1, 1, root 2. This one, since opposite and adjacent are the same at 1, then we can fill them in as 1s. And then the hypotenuse has to be the square root of 2. There's less ambiguity here because opposite and adjacent are both equal. And so now this gives us a ratio, a completed ratio of corresponding values. So this ratio is 14, well, it doesn't matter. We can go in either order. 14 over root 3 over 1. Now there's a problem with a few of your submissions. So there was one problem, I think it was 29 from one of the homeworks, and it was a nightmare to grade because there was a way of doing it that I did not think about, that a lot of you did it, which was natural. I'm biased, so I didn't think about it that way. So the way you all did it was very natural in tandem with how I explained it. But there was a lot of complex fractions I noticed for a lot of your final answers, which I did say I didn't try to take off any points for it because I didn't say anything about, I said in class, you can leave the final answer. So I didn't take off any points, or if I did, let me know that I did and I'll give it that. But only contingent upon how the problem could be interpreted. So this is the first thing that it makes me think of right here. This right here what a lot of you did, or what a lot of you tend to do with complex fractions, you write it like this.
Yeah.
And that is a nightmare to try and interpret. Because doing this versus doing this, that is different. And without the parentheses, it's hard to interpret. So that's why complex fractions are a nightmare. And if anything, I would encourage you try and not have complex fractions. So technically the completed fraction or the completed ratio would be this. And I'll leave it like this for now. You could simplify it, but that is the completed ratio. And let's see, what's another ratio that we can solve for?
N over 1.
Okay, we can do that. N over 1. And we would want to go in that order because n comes from the same triangle as that numerator, and then 1 comes from, these ones come from the same triangle. And this one's really easy to solve. I mean, we're dividing by 1 in both cases. I think it was you I was telling that, was it for n, you should expect the same answer?
Yeah.
And so this is, because a 45-45 triangle, the two sides are equal, then this has to happen. So that's n, so that one's easy to find. So what about the other one? So let's pick orange. So the ratio we had was 14 over the square root of 3. Really, I don't have to put over 1 because dividing by 1 doesn't do anything. And so, well, I guess I will anyways. Whatever. So we're trying to figure out the ratio of square root of 2 and q.
I think Q's supposed to be on top.
Yeah, it's supposed to be on top. I was testing you all, and not because I am a flawed person. Okay, so Q should definitely be on top, 100%. You were definitely right. Okay, there we go, fixed it. So Q definitely has to be on top because now these two come from the same triangle, and these two come from the same triangle. There we go. And now we can cross multiply like this. It looks really messy, and that's what made this a challenge problem. So this would be 14 over the square root of 3 times the square root of 2 is equal to q times 1, which is really just q. So wasn't that a fun problem?
I was sitting here doing it at home, and I was like, my dad was like, are you almost done with your homework? I was like, yeah, I'm on the last problem. He asked me like 20 minutes later. I was like, yeah, I'm on the last problem. He's like, you're struggling? I was like, no, it's just a lot of work.
Dude, I breezed through the first however many questions. I got
And
to this
then
one.
you got to this one, you're like,
I sat there for like 30 minutes and I was like, this sucks.
Don't expect this on the test. Yeah, don't expect wonky answers like this on the test. This is just definitely more so challenging, somewhat encouraging to an extent of reaching out to your professor if need be. Because again, I don't mind helping trig. college algebra is kind of a drain. Trig's pretty cool.
Well, I do hate college algebra too, because that class was miserable.
No comments.
It was miserable on all levels.
Yeah, it sucks that I always am falling asleep during the lectures. The problem is I teach the lectures.
Do you have to teach on Fridays for that class?
Yeah, I gotta teach on
That's
Fridays.
miserable. I hated going to that Friday class.
I don't like going to it either, and I teach it.
Yeah, I'm pretty sure my professor that I had for it didn't like it either.
Well, that is that problem. Are there any requests for other problems? Perhaps say, let's see, what else is out there? And online people, you're welcome to have any problems you want me to work out. I don't mind.
One more thing, for 49 through 56, do you want us to show work? Because all I did was use the values from the chart on the page before.
So what section?
2.1 still, it's
2.1.
49 through 56, they're all the same, and it gives you the chart on the page before.
Unless it says show your work by, I think at least one test problem I've had for some tests, I said, tell me what opposite, adjacent, and hypotenuse would be for the triangle. So if it were like 30 degrees, I would say, all right, well, 30 degrees, and of course that matches up to a special triangle. I'd say, tell me what opposite of 30 degrees would be. That would be 1. Adjacent would be the square root of 3. And 2 would be the hypotenuse. So you would just state it. Just so I make sure that you had some sort of intermediate understanding instead of calculator herp derp, you know.
Yeah, no. Well, I didn't even use the calculator for it. I saw the chart.
Well,
That's all I have for right now. I haven't done 2.2 yet.
Two point one and 2.2 is due tomorrow, right?
yeah,
Okay.
tomorrow. Would you like me to go through any other problems? I mean, it'll make it really easy for me to grade if I,
Are there any values for number 10, or is it all the letters?
did I take out number 10?
I don't believe.
Where are my notes? You know, if I left it, then oops. Yeah, it's not a big deal.
Took out 13.
Took out 13. Darn it, I meant to take out number 10. That's not a big deal. I really don't care. That's not that big of a deal. Okay. Well, back to your question then. Yes, it's all going to be letters.
I thought it was easy, but I thought it was too easy when I saw the letters. I was like,
It tends to be a common impression with math.
Yeah.
It's too easy.
it's like on the scan contest when you have 4 B's in a row, and you're like,
Man, that's giving me goosebumps just thinking about it. I haven't had to take a Scantron test in 5+ years. Still gives me goosebumps. let's see. So what problems did I assign for those two sections? And is there anything I can at least provide a hint on? Let's see, 7, 8, 10, they should all be pretty straightforward. I apparently took out 13, which that does sound familiar. 26 through 28. 28, if you didn't do distribution, you probably got it wrong, hint. Number 28, if you did not distribute somewhere in that problem, you probably did it wrong. I'll give that as a hint.
Well, I knew, like, the first time I did it, I was like, wait, I did something wrong here. And then, like, I looked, I was like, oh, I only distributed, like, halfway, you know? Like, I only distributed the time on the, like, I changed.
Wait a minute, didn't you ask me this?
No, I asked you, number 33, because I had, missed the,
Oh, right. Which is, it's the same idea, having to distribute.
so you're supposed to distribute on 26, 27, 28. It's like for 28, I got sine, and then parentheses 70 degrees minus theta.
Yeah, that sounds right.
Oh, okay.
Yeah, you must have.
I didn't distribute on that one.
Yeah, because when you distribute, you would get, 90 minus theta minus 20.
Yeah.
And then you get 70. Okay, cool.
But I did distribute on, 33. Didn't.
Good.
Okay. I was about to say, because I didn't, I didn't see it 82 really.
Well, then I really hope I'm grading those problems. Make my job easier. Let's see, what else? 33s, 49. Okay, so back to what you were asking about. So really the hope for 49 through 54 for now, I'll talk about the other two in a second. But the ones all pertaining to 30 degrees, the hope was that you would do as much scratch work, at least on the homework, as I did for example 4 here, which was draw up a triangle and then fill in the triangle with the values, say so pretty much exactly what I did for example 4. So for problem 1, what I did was, I hope I remember this correctly, what I should have done triangulate, fill in the parts of the triangle, so that's 45 degrees, so it would be 1 root 2, and then give me all the trig values or whatever it's asking for.
Okay.
And then for 45, same thing. In fact, you notice that 55 and 56, they're specifically not asked here, so they're asked in the homework. So that was kind of my hope. It doesn't say show a triangle, so I don't want to be unfair and say you had to draw one.
Yeah, I did it.
So
Yeah, I didn't either.
So it doesn't say you have to, so I'm not going to mark off for not drawing one.
I just didn't want you to be like, how did you get these values of, you didn't show me work? I was wondering,
Yeah,
more or less than,
there's no definitive answer on how much work to show or not. That's why on the test, I try to say, like on the test, if I were to ask one of these, I would say, draw a triangle on your own, and then, get out of my way. So draw a triangle on your own. So you would draw, say, 30 degree, here's the X, Y, all that stuff. Draw 30 degrees or something. This is what you would do on your own. I would never see this. You would fill it out as, so what's across from 30? It's 1, root 3, and 2. So then I would ask, what is opposite, adjacent, and hypotenuse? and then you would say 1, and then square root of 3 for adjacent, and 2 for hypotenuse, just so I know that you're getting the values from the right place. So this, I won't ever see this, but you would take that, and then this is how you would translate it onto the computer. Or I might ask for, actually, no, that would be pretty straightforward. And again, when you type in, say, if you're trying to type in A is the square root of 3, you could just say A is SQRT 3 or something, and I know what that means. I mean, again, my summer class, they figured it out really quickly. It was pretty easy to translate. Oh, let's see what else was there. There it is. And then 76, I did that one. So about 2-2. Anything here worth?
I have a question on 2.2 on 62. I did all the work, I just wanted to make sure I did it correctly.
Well, how about this? I will check your work. You come up here and you write it in front of everybody.
Really?
Yes. I did this for my 105 class, and it was actually really interesting. So let me give you a fresh palette to work with.
That's so cool. You can like just write on that.
So let's see. So fresh palette, hide that. If you need more space there, then you click on colors and eraser.
Oh, cool.
So have at it. Sit down if you want to stay. And you could rest your palm. You could rest your palm.
Oh, I can?
Yeah.
Oh.
It doesn't. It's like, yeah, all that stuff.
Well, that helps out a lot. 3. Oh wait, I'm sorry, how do I erase? Is this it?
The little eraser.
Yeah, press the eraser.
Right.
So it's below the highlighter.
This, right?
Yeah, you just hit it with the pen.
Oh.
There you go. I haven't had a good opportunity to text in class in a long time.
Wow, this shows how terrible I am with technology. Okay. Oh, no. How do I get the eraser off to back to pen? Like I'm trying to hit the pen and it's not doing anything.
Well, I mean, you're trying to do the pen?
Yeah, to like draw.
Yeah, you can just draw. I mean, what's wrong with it?
Oh my gosh, now it's working. Sorry guys, this is super messy. That's it. Ta-da.
Plus. Is it good? Why 60?
Because it's past the 270, but it's on 360. Like, it's on quadrant 4, so wouldn't I subtract 360?
Quadrant 4 is fine.
The one
The
in
330 is fine. The 60 is off.
the
The
one
90 minus 30,
you didn't have to do anything with it. You just had to keep it 30, right?
you just keep the 30. 30 is the quadrant 1 answer. Yeah, you could just completely toss that. Because in quadrant 1, your angle is your reference angle.
Okay.
So when you got 30, and you know that, so for completion purposes, for anyone at home wondering why you drew these triangles as you did, why did you draw a triangle in quadrant 1 and why did you draw one in quadrant 4?
Because of, forgot what it's called, but that thing you told us all students take calculus, and it's cosine, so it's positive, and then the first quadrant's positive, so I'd use those two.
First quadrant is positive.
Yeah.
And the fourth quadrant is positive for cosine.
Yeah.
So because cosine is positive, you know that the angles have to be in quadrants 1 and 4. So, I guess, let me go ahead and. Yeah, you're good. You're
I'm good? Okay.
You got it right. So, yeah, since cosine is positive, we know that the angle, there's one angle in quadrant 1, because everything's positive in 1, and quadrant 4, because when you think of all students take calculus, where is cosine positive? Quadrant 1, not quadrant 2, not quadrant 3, and quadrant 4. So that's it. And since you found a reference angle of 30, given the special triangle, then from the reference angle, you can figure out, well, since one of them is in quadrant 1, then your reference angle is your angle. In quadrant 4, that's where you do 360 minus. And so that is it. So it is about 3:15. If anyone has any questions, I'm happy to stick around. Other than that, you are left on your own to figure out whatever. Homework's due Friday at midnight if you did not physically turn it in to me. And that's all I got. Have a good day.